This is Greg with IIoT World, and I'm here with Galeal Zino, and Galeal is the CEO of NetFoundry. Welcome, Galeal.
Greg, pleasure to be here.
You know, you often challenge in some of the things that I've read that you've written, Galeal, the role of traditional network access in cybersecurity. Can you explain why you believe the network model, is the real issue and how removing that underlay access, helps secure IIoT and OT environments specifically?
Yeah. Well, we had two unique aspects, and they sound maybe a little bit trite, but one is
Okay.
visibility and two is starting from scratch. What I mean by that, Greg, though, is because we have customers, global customers, ranging from critical infrastructure and OT to distributed IoT to large enterprise hybrid cloud and APIs. We have this wide range of customers, which gave us visibility into exactly what you just articulated, which is, hey, actually, the big problem is the network. And I'll get to what I mean by that.
Okay.
But two, and as importantly, I mean, these things go hand in hand. As a startup, we're able to look at that problem and say, okay, how do we solve that problem in a way that is best for our customers, is best for our partners, is best for the world? Like, not a big company looking at that problem and saying, oh, yeah, the network's broken. Let's do a SWOT analysis and figure out how we can extend our current products and stretch over here and build on this strength and all this type of stuff that at the end of the day may or may not like solve the problem. So we had the visibility of the problem, and then we had the focus of a startup, just go solve it from a first principles approach. And I think that's why we've ended up with such a unique solution to the network problem, which I'm sure Greg will get into.
Sure. No, I can appreciate that. I think you recently launched an on-prem version as well for air-gapped environments, which I know happens a lot more often in the critical infrastructure side. How is networkless connectivity helping secure critical infrastructure, like whether it's manufacturing operation or it could be an energy facility or even water, without relying on traditional firewalls or VPNs?
Yeah, I like your word networkless, and I'll just take one step back. What we did is convert networking to software. And what I mean by that is TCP/IP networking, fantastic. It powers the modern world. On the other hand, it's born a certain way. It was designed a certain way. It's fundamentally insecure, and it's fundamentally bounded and restricted by infrastructure, IP addresses, etc. And as such, the job of a network designer, administrator, operator has been incredibly difficult because you're starting from something that's inherently insecure and it is quite restricted by infrastructure. When you flip that and you turn it all to software, then not only can you take this networkless approach where you do things like identity and authentication and authorization on the security side, but also things like visibility, telemetry, audits, controls, integrations. You do all that as software, and it actually makes it viable. And as you said, because it's all software, we found quite a few customers that have said, okay, like we're using this maybe for, let's just say, distributed IoT devices. However, I have this other use case over here, and let's just say it's manufacturing, and it may or may not be air gapped, but at the very least, I don't want to have to depend on external connectivity, just from a uptime reliability type perspective. And since you, NetFoundry, have reinvented networking as software, why can't I just put that whole stack, so to speak, in my on-prem environment for those type of reasons, and in some cases even air gapped, which we've done as well. And what we realized was, yeah, actually, that makes sense. And like the use cases they wanted to do were your typical kind of OT microsegmentation, secure quote unquote OT IT convergence, these type of things, which again are just incredibly difficult to do with like IP addresses and VLANs and et cetera. But as software, they become very doable. And so that kind of drove and we only kind of recently announced this, but we've been doing it for a little while. This kind of drove that kind of on-prem option that you're referring to.
Interesting. I know a lot of times many OEMs struggle, to add strong security without making their products harder to use or harder to deploy or integrate. How can secure by design connectivity be embedded in industrial devices without increasing costs or even driving complexity?
I think you hit the exact issue, right? For many years, we kind of equate stronger security with some type of trade-off. And that
Right.
trade-off might be cost, or it might be complexity, it might be friction or user experience. And oftentimes those trade-offs are just unacceptable. And so I mentioned when we kind of looked at this problem and we said, okay, let's not force people into that rock and a hard place. Let's not make security a trade-off. If we can solve this from scratch, how would we solve it so that security can actually simplify operations? And it does come down to that age-old term of secure by design. Because if you do secure by design, especially for a network, which, again, historically they were inherently insecure. If you make that thing secure by design, then what don't you have to do? You don't have to try to bolt on a bunch of day two things to try to make something that's inherently insecure secure. Like that's a really difficult problem, especially with modern architectures, which are incredibly diverse, heterogeneous, and distributed. So yeah, you're 100% right. Secure by design actually is simpler. And just to take that one step further, because you also kind of alluded to this new model. What we wanted to do was make it so that, let's say you're putting a connected device into a manufacturing environment.
Okay.
This could be infrastructure like a PLC. This could be a robot. This could be a smart device, a smart pump, whatever. Um, as you kind of implied, historically, in order for that to happen, there had to be a whole bunch of engineering and operations work, right? You weren't just plugging that thing in and magically it working with proper security, visibility, predictability, telemetry, et cetera, et cetera. Like quite the opposite. And I like to say, like our North Star was that connectivity becomes part of products in the same way that like electricity is a part of something that you or I might buy, Greg, and plug into an outlet. In other words, like we plug that thing into an outlet and it works. What we're not doing is figuring out like, okay, how do I wire this to the whatever the nearest substation? Or how do I make sure there's resiliency across multiple substations? Like that's not there for those type of products.
Right.
And so from a first principles perspective, if we can embed secure connectivity into the product as part of its software, like natively, so that literally when you put that thing onto not really a traditional network, but what's an overlay network, then it can be secure by design. Make it essentially as simple as you and I plugging in an electrical device, while recognizing that obviously if you're plugging in something quote unquote to an OT overlay network, you have to ensure certain things like identity authentication, authorization, et cetera. So that's the model though, Greg. It allows again from smart pumps to PLCs to firewalls. I mean, you name it. Because we put the network in the software, you just build that software right into your product. And it just makes that product a lot more robust. It becomes what I would call a secure by design product. And it enables OT and IT operations and engineering a much more robust and simpler model to actually implement that thing.
Well, I mean, it sounds like a revolutionary step forward. I mean, and it sounds like you work with a wide range, if you will, of industries as well, from manufacturing to infrastructure. Can you share a few use cases from an IIoT perspective where the design, your secure by design approach was a major impact, and what was that impact? Whether you want to talk about critical infrastructure or the
Yeah.
machine floor or shop floor would be great.
I'll start with manufacturing.
Okay.
This is something that's deployed in different types of manufacturing sites on multiple continents at this point in time. And to be a little bit specific, there's three general problems so to speak, that our customers want solved, or even opportunities that they want to capitalize on. And they range from microsegmentation within the OT environment. Um, Listen, traditionally, number one, it's been very difficult to do that. We're talking about things like VLANs and IP addresses. It's not even always TCP/IP. You have legacy devices. You have things that are resource constrained. They've been there forever. They're going to be there forever. It's a very difficult problem to solve. And quite frankly, historically, you didn't necessarily have to solve it because you could essentially defend the perimeter enough that you could have pretty good conviction that nothing was kind of coming from the outside into that OT environment. So like you knew if something got into that OT environment, it could be problematic. And if you were a huge, huge company, you probably did invest in kind of microsegmentation with these like networky type things. But there's a whole lot of cases where that just wasn't viable or possible. And again, because you can make sure it was like outside world OT, that may have been the right decision at the time. Now what's changed is those OT environments are increasingly not quote unquote air gapped, either because they're
Or you may
talking.
think they are and they're not, right?
Yeah, that could be too. But even things like, I mean, I know digital twin has certain connotations, and so does AI, and so does predictive maintenance. But those things are, we see them increasingly, and they're increasingly important. And there's legitimate business cases where, as a manufacturer, you can be more productive and better serve your customers and be more efficient in all aspects, energy, productivity, et cetera, by adopting some of those programs. But the big but, like your OT environment is not going to be isolated like it was. So one thing we've been able to solve is microsegmentation within that OT environment on existing infrastructure. So just at a high level, because we've turned this thing into software, we've made our software um, able to deploy on everything from very small devices. I mean, just think of a Raspberry Pi, like not even like a newer Pi 5 board, but like a Pi 1 or 2. Think of like an NVIDIA Jetson. Think about those type of things. Think about old PLCs, firewalls, switches, routers, reverse proxies, infrastructure you already have in that OT environment that you can easily deploy our software on. And then think about devices in that environment where you are not even a very lightweight approach, like a lightweight agent or gateway, like I'm describing, even that, you're just not going to put on that hardware. However, often because of these kind of initiatives I described earlier, you have this software that's going on that device. And maybe this software is doing things like emitting some telemetry data, might just be, some MQTT, it might be, very basic kind of data. Using our SDKs, which is just a fancy word for, a shim that goes with that software, such that, let's say, that device, when it wants to go talk to something, that shim kind of wraps around the network interface and it says, okay, like, great, you want to emit some telemetry data. Let me do some zero trust things so that you don't have to. Let me do X509 certificate-based identity authentication. Let me do least privileged access authorization. Let me do encryption, telemetry visibility, these type of things in the software so that as soon as you deploy that software to like these sometimes incredibly distributed devices, in other words, across 40, 50, 60 manufacturing plants around the world, you don't actually touch the devices. You're just deploying the software. And then the software has the built-in, what I'm just going to call native zero trust overlay. We can kind of get deeper into details later if we want. Such that things like microsegmentation become second nature. So if that thing needs to talk to that thing, great. It's just these identities have a policy that says that they can talk to each other. And by default, this thing can't talk to anything else. And it's all built into the software and it's all controlled via policy. So, okay, microsegmentation is one really cool use case we solved in manufacturing. The second one is I'm just going to generally call it OT-IT convergence. I won't go into great detail. The only thing I'll say is what we make sure of is that OT network is literally not accessible from the underlay networks, even the IT network, and certainly not a vendor network or a cloud or an edge or anything like that. We introduce a concept called application level connectivity, such that least privileged access is not like that IP and that IP. It's like, no, this API is surfaced. It's outbound only from IT. Excuse me. It's outbound only from OT.
Okay.
And it's only going to work if it's identified, authenticated, authorized. So those are two of the like really important use cases that we solved in manufacturing specifically.
Got it. Maybe I'll ask you to take out I always say the crystal ball, if you will. We're seeing this, a convergence of artificial intelligence and zero trust with coming along with hyperconnectivity as, the different bandwidths start to increase. How do you see these trends reshaping industrial cybersecurity, and what should companies be doing now to prepare for it?
So at the end of the day, AI is software, right? So it's a tool. It's a tool that the good guys, quote unquote, can use. It's a tool that the bad guys, quote unquote, can use. What I'm hoping is that we open source and open interface and standardize and democratize on the good guy side of AI. As a somewhat trivial example, if I was to go build, an LLM and train it so that it could do really good analysis of like typical SOC SIM type data, um, I would hope that whoever does that would open source that, like fully open source, like the weights, like everything, fully open source that to the community so that everybody could take advantage of it and build on top of it and improve it and fine train it and everything else. That has enormous upside because quite frankly, the opposite is certainly true. And this is an advantage that cyber attackers have, right? They, to a much greater degree, share, quote unquote, their best practices. They are collaborating. They are working together, informally and formally, on essentially sharing exploits and how to exploit them, tooling. You have an actually incredibly sophisticated supply chain of bad guy actors where they're each doing very specific things
Sure.
in combination and sharing kind of this IP. And like on our side, on quote unquote the good guy side, it's like almost the opposite. Like you have a lot of silos and a lot of great work done in silos. So I'm bullish on AI. I'm bullish specifically on LLMs uh, in these kind of SOC type contexts, with the only caveat that I think we really need to recognize the importance of open sourcing, open standards. And this is a playbook we've seen. We've seen this in the Kubernetes ecosystem. We've seen this in the Linux ecosystem. Like we've seen this in other places. I just want to make sure we emulate it when it comes to AI.
Great insight. I appreciate it. Well, thank you for sharing with us today.
No, great questions. We could talk for forever on it. And I hope we get to talk about it again, Greg.
Indeed. Look forward to it. Thanks so much.